Good morning, dear students. Good morning, all of you. How are you all? Fine. Okay. So, dear students, in this video, we are going to discuss about the extraction of metals, and we will actually see that the different types of metal, different reactivity of the metals, and that can be extracted from its ores by the different methods. So, very first, during the extraction of metals, you will see that the major steps we actually talk while extraction of metals. And first of all, whenever you will get some of the ore means some of the impurity it will contains, some of the metal is there. If it contains there sulfide, chloride, carbonate, nitrite, if it is in the combined form, then that can be called as ore. So that ore, very first step, that ore's concentration is essential. You can see this one is ore concentration, and in this one ore is purified and concentrated. Purified and concentrated means unwanted impurities, unwanted rocky particles, gangue particles, it should be removed from the ores, and we have actually removed in very first step, and that one is ore concentration. So ore is actually purified and concentrated, and one more special term is used, that one is enrichment of the ore. And in the enrichment of the ore, the same thing is there, gangue particle is to remove. Then after reduction to crude metals. Okay, so suppose you have purified the ore metal. Now your ore actually contains some of the oxide, and that oxide, this is the oxide, you have to reduce it into the metals. But that metals is not the pure metal, that is crude metals. So you have to remove some impurities. If it is still present into to the crude metal, we have to remove that one. Okay na? And for that one it will go to the next step. But in this step, reduction to crude metal, reduction means you will use some of the reducing agent. If some of the metal oxide is there, if suppose PbO is there, if suppose ZnO is there, then you can use carbon as a reducing agent. Carbon will take its oxygen from the zinc oxide, from the PbO, and itself it will oxidize into the chemical reaction, but it will reduce zinc oxide and lead oxide. Okay, and you will obtain the metal, and that one is a crude metal, that one is not the pure metal, and hence it will go for the third step, and that one is refining to obtain pure metal. And refining is the process by which pure metal can be obtained from the crude metal. So you can see, to obtain a specific metal, purify and remove unwanted metal impurities, and that one we actually do in the refining. So there are various methods for the refining. Electrolytic refining is one of the special technique we actually implement for purifying the reactive metal. Okay now? So that one is all the steps we require whenever we are trying to find out some of the metals while extraction. Okay now we will see the next one. So here you can see that I have taken the reactivity series, and in the reactivity series you can see the various types of reactive metals are there, and in this side it is written over there that if the reactive metals are there, suppose Na is there, potassium is also written over here, potassium, Na, Ca, Mg is there, these all are called as reactive metals. And in that, if you are seeing the reactive metals and its ores are there, then you can use this method, extracted by electrolysis of molten chloride. Okay, na? NaCl, Cl2, MgCl2 is there, then it can be extracted by electrolysis. Okay, na? If the moderate reactive element are there, moderate reactive elements and its ores are there, then extraction by reduction of oxide using carbon, simply you will get some zinc oxide, some Fe2O3, PbO, CuO. So simply you can use some reducing agent, and that one is carbon. So carbon, I have discussed that one. Okay, now if you are seeing some ore which contains sulfide, and in that one what you have to do, you have to remove, you have to do the roasting, you have to do the roasting, for the sulfide ore you actually apply the roasting, and that one will convert this into the oxide ore, and from the oxide ore you can use some of the carbon, some of the reducing agent, and it will convert into the its crude metal. Okay, now that you can see here, extraction by electrolysis of molten Al2O3 dissolved in cryolite. Okay, so here you can see the extraction of metals at the top of the reactivity series are very reactive. Those which actually lies at the top of the reactivity series, that one is very reactive, so bonds between them, their compounds are very strong, and if I have to break that one, you will use this electrolysis process, and electrolysis process, through that one we can convert this to Al2O3 into Al and oxygen, and this aluminum and oxygen will go one by one at the cathode and one by one at the anode. Okay, now so we have seen that one. Oh, please wait. Okay, so electrolysis process, in that one we will use one of the chamber. Okay, and cathode would be there, anode would be there. Okay, and aluminum and oxygen will go and attracted towards their respective electrode. Okay, now you can see the extraction of metals, why we are actually talking about the extraction of metals. Extraction of metals actually involves getting rid of the unwanted rock. Okay, if some of the gang particles are there. Okay, now if some of the unwanted impurities are there, they can actually remove that one from the extraction, and obtaining pure metals from the minerals. If some of the minerals are there, then we can obtain the pure metals. That's why we are actually talking about the extraction is very essential one. Okay, now extraction is very essential one for obtaining the pure metals. Okay, now in this one we will actually talk about the decomposition reaction. Here the decomposition reaction means there are different types of decomposition, but here we have taken the heat. That means this one is the thermal decomposition. If any of the breakdown you are seeing in the presence of a heat, that one can be called as a thermal decomposition. So here decomposition means one single substance, this one is a single substance, in the presence of heat, that one will break down into iron oxide, sulfur dioxide and sulfur trioxide. So from one substance it is actually giving a number of different substance. So that one is a decomposition reaction, and it actually takes place in the presence of a heat. So that one is the thermal decomposition reaction. And here you can see one more, here it is written decomposition of calcium carbonate. Decomposition of calcium carbonate will give calcium oxide, carbon dioxide on heating. Yet again it is a thermal decomposition reaction, and in that you have seen the decomposition actually takes place in the presence of heat. After that one breakdown, calcium carbonate is decomposed to give quicklime and carbon dioxide. Okay, so this one is the decomposition reaction. Okay, thank you.